Next again, we have okay. Read the question. That there are, I think, okay, two more questions are there. Well, let me wind up. If I move the spot, there's a mirror. There's a source is there here. There's a source which will emit light. There's a mirror. I'll move the mirror with a velocity with a speed v in the vertical direction. Now, what are the questions like? What will happen to the length of spot formed on the screen? This is a screen. This is a screen, and the mirror is let it be at a distance y. So v equal to dy by dt. What we can write it. So what happened to that patch or the bright spot or bright patch formed on the screen? Now, why do the bright patch will be formed? What are the conditions? Because the ray emitted by the source after reflection will fall. Okay, this part of screen will get illuminated. So for different positions, we'll see what conditions will arise. Okay, let me start with the initially. The ray after reflection, we have to follow the laws of reflection here. Fine, this will be. Then next, when the ray goes, strike the other end of the mirror after reflection. It's again a geometry based. You have to see that the angle of incidence should be equal to angle of reflection here. Angle of incidence should be equal to angle of that way you have to draw it. Then again, the mirror will take this position. Okay, let's again send a set of rays. Now I'll send a solid one so that you can see the difference. No. What was earlier length of the patch? The patch length was earlier it was AB. No, A1, B1, and the patch length is A2, B2. And if you look at this distance, will become equal to this. So the length A1, B1, in fact, equal to A2, B2. So what happened? The length of the patch. Remains the same. So the size of the patch remains same. Shall we put it? See, now intentionally I'm doing some mistakes so that you can understand. Are we really following the laws of reflection? This is the primary question. You have to really take help of the protractor here. So when you draw it, you have to see that this will be the, in fact, it will come like this. Now you can ask questions. Sir, earlier you drew in one way. Now you are drawing. How do I can justify that I'm correct here? So I'll take help of. Okay, this ray diagram is what now is going to help me a lot. Now you can ask questions. Sir, what is this? Earlier you said something and all of a sudden again you changed it. Yes, in fact, see like uh, when you're drawing diagram, you have to follow certain mathematical rules, the laws of physics. The angle of incidence should be equal to angle of reflection. So here, if you look at, if you draw, if you look at that angles, theta. I have to just see if you find very difficult to take scale and protractor and analyze. The length of the spot will not change. There's nothing called like A1, B1. The spot, what happened? Length of the spot, length of the patch, bright patch. What's like a length of the bright patch remains same and will not move on the screen. I think it's about the diagram. Huh? So what is the like usually let me take this a yellow color source of light. So what we see is like the patch will be this one. So this yellow color, I'm taking the sodium vapor lamp. Then I can definitely on screen I can see that yellow color patch, sodium bulb. If you find very difficult, take scale and protractor. Or else through you should draw a diagram. So you can draw a diagram where you can show wrong, but something you have to be careful with the angles. Got the idea? So length of the bright patch remains same and the patch will not shift also. Got it? Huh? Okay, now the last one more condition. Now let me move the mirror. Earlier I was moving along Y. So here what I do is like I'll just move parallel to the screen. That's the same conditions. Yeah. Look at this. Now let L be the length of the mirror and it is moved with uniform velocity. The mirror is moved with a velocity. What will be the speed of the patch on the screen? So what is the question? Find the speed of bright patch formed on the screen. Now what we have to do is like you have to take two positions of the mirror. Okay, there's a one position is there. So let me get into the ray diagram part. The initial one I'll show by dotted after reflection. Now the mirror, I'll shift it. It will occupy the new position. So let me take the solid lines for the new position. So first they will strike the then you see this. All these are some like a geometry based, no? So definitely little bit some struggle will be there. If you can manage that, I think the geometry part you should be very good. The triangles, so most maximum will come across only the triangles condition. No? And now the initial distance, these distances will take it. So they are going to help us a lot. Now you analyze the diagram. So let this be X. This is L. And from the geometry, okay, we'll do one thing. This is X, no? Okay, no, huh? I think we were here, no? So the mirror was moving with a velocity v. So let me, how much of distance the mirror has moved? Here you see this one, the distance d. How much the patch has moved here? So this is the source S. So we'll take this point as A and this corresponding point as B. Let this be A dash. Let this be B dash. So what is our interest like? What is A dash? So when this end of the mirror undergoes a displacement, so how much displacement will be equal to D? You can see from clearly. So when the mirror undergoes a displacement D, then what will happen to so how much this patch will move? Actually, this end, how much will move? D plus L. Then how much this A will move? For the A earlier was for this portion of mirror, the point A was here on the screen. Next short pen corresponding this particular point of the mirror, the A dash will be here. So the displacement of this will A dash will give the displacement of patch. This is what we have to find out. Okay, for that, let me take help of the conditions available. This distance is L. So this distance should be equal to X plus L. What about this? This distance will be X plus L plus D. So therefore, what is this distance will be? How much the mirror has undergone displacement. So look at this end. Earlier it was here. Now it is available here. What is the displacement of mirror? L plus D. In that interval of time, the point has shifted from A to A dash, corresponding to this point of the mirror. So if you can calculate A dash, the problem will be solved. That A dash has to be expressed here now. So how to calculate this distance A dash? So now we know this distance will be from A to here we know L plus X plus D. Okay, this one. And this also X plus L plus D. In that, I should calculate this distance, P. Okay, so I think I need some place to do calculation. Let's get into this one. If you can calculate the distance AP, it's old. So what is the distance AP? X plus capital L, small l will take it. Yeah. So many different symbols. This will be X plus, so this will be 2X. So this distance is SP, or we'll do one thing. AP is what? SP minus SC. What is SP? SP will be X plus L. Oh, sorry. SP is what? X plus L. What is SA? SA is 2x. So this will become L minus x. This is AP. So overall distance A dash will calculate. A dash should be equal to AP plus D plus X plus L plus D. A dash. So what is AP? AP is equal to L minus X. Now what is the displacement of this end of the mirror? L plus D. Then in time t we'll write it. The displacement of point A, the displacement of spot from point A to A dash is how much? 2 times of L plus D in that interval of time. So what is the conclusion now? So all together now what we can write it as like, so with what speed the patch will move, therefore moves with a speed 2v. If the, what is the speed of the mirror? The mirror moves with a speed v. Again, the ray diagram very, very important. The patch, in fact, will move. What is the patch, sir? I'm not seeing what do you mean about what you are seeing the patch. I'll show the patch. The patch earlier was this much. Oh, all the things. This was the patch. Now, finally, what happened? The patch, how much it has become? AB was a patch. Now, A dash, B dash will become the patch. It has undergone displacement. The patch will not be there. Patch will undergo displacement. I'm showing the by color the patch which was earlier here now will be available here. I'm keep on writing. Okay, this is screen. Okay, we'll end up the class here.